I'm Cody, and I'll show you our branch circuit right over here. We're doing the vertical log splitter, and zoom in right there. Alright, first thing, we have our intake filter with the bypass check valve, and then that goes into our pump, which goes through a gauge reading PSIG. Then we have a regulator set at 2000 PSI. We have our flow control to limit how fast the cylinder goes, and then that goes into our directional control valve with the open center. We do that to conserve energy when we're not using the cylinder. That works by the flow going directly straight back into the tank. Then we have our lever to operate our cylinder. One way goes out, one way goes in, and then that goes to our double acting cylinder to split the wood, and that goes back to our directional control valve and back towards our tank. But before it gets to our tank, it will go through a return filter with another bypass check valve, just in case they get plugged up. And
okay, I'm Nathan, and let's walk over here to our circuit that we have set up. So right here we got our pressure right through a hose to our flow control to adjust the flow as in the diagram that we saw. And this is to a gauge so we can see how much pressure we got. We just go into a directional valve so we control the way the cylinder goes in or out. And then cylinder and all of this goes back to the directional valve to the tank. And if we turn it on, we push it out, slowly moving, so all the way out. Then if we adjust the flow control and then kick it back in, it's a little faster. So for example, if you have like a piece of wood right here, you can adjust how fast you want it to hit. Imagine this is like the slung and you hit it, and it'll break the wood in half, and then it's already cut. And for our circuit, we had a vertical log splitter, so kind of imagine the cylinder is kind of more up, so it cuts down on the wood. And from there, we'll go over to Brian.
Hi, I'm Brian. I'm going to go over some of the calculations we did. So basically for the vertical log splitter, we went with a 6-inch diameter by 24-inch, which is 24 ton, approximately 50,000 pounds. Our max pressure was 2,000 pounds. Our flow rate was 35.25 gallons per minute. Our horsepower was 36.35 horsepower because of how big the cylinder was. And then we figured the cylinder speed was about 5.2 seconds to extend and about 2.9 to retract. The max static output force or torque is 56,548 pounds at 2,000 psi. Our horsepower requirement is 36.35 for 50,000 pounds. Our pressure line was 1 inch and our return line was 1.5. Our tank size, they say whatever your gallons per minute times 2, so which would be a 70-gallon tank. And we choose the soybean oil because it's got large temp range, excellent lubricity, and excellent fire resistance. And then we went with a really strict clean code because of the flow controls and the type of fluid. Thank you for watching. Have a good one.